Okay, guys, so we're going to talk about the different components that make up our lung volume. Okay, so within our lungs, the total capacity that our lungs is really able to hold is not as much as you would think. I mean, it's a lot, but when you look about what you're actually using on a regular basis, it's not a ton. So our total capacity equal to about 5,800 milliliters. So really, that's not a ton, right? When you think about it. So that would be what's considered to be our total volume on the left-hand side. So I'd like you to kind of write these things down as we go through this. So the first component we're going to look at is something called tidal volume. So I have that highlighted down here. Tidal volume is the volume of our normal breath. So that is what these just small peaks and valleys here are. This is our tidal volume. This is what, when we're just sitting on the couch breathing, this is how much air we're breathing in and out, okay? And so our tidal volume of that 5,800 only makes up about this much right in here. Okay. And the amount of volume of our lungs that is in this area right here for our tidal volume is about 500 milliliters. So not very much of our total capacity. Okay. And so then with that, we have our, when we breathe in as much as we possibly can, and we breathe out as much as we possibly can, that is going to be called our inspiratory and expiratory reserve volume. So from that point in which you have breathed normal to when you can breathe in as much as you possibly can is called our inspiratory reserve volume. So we're going to color that green. So this is the additional volume of breath that can be inhaled after normal inspiration. Okay, so that is technically this region right here, this peak. And as you can see, it's from the point of our normal breath all the way up to our maximum capacity that we can breathe in. So for our diagram over here, our inspiratory reserve volume, we're going to do that in green. Should be this section right here. Okay. Volume for that is approximately 3,000 milliliters. So that's quite significant. Okay. So then we have to have the opposite of inspiration, which is expiration. Okay. So I'm going to color these so we remember. Okay. So expiration, we also have an expiratory reserve volume. So our expiratory reserve volume is the exact opposite. So it's this region right here. So our expiratory reserve volume is the volume expired after normal breath. So if you breathe out normal and then breathe until you push all of your air out. So if you're like, and you breathe the rest of the air out, that is what is considered your expiratory reserve. And so that is this next little section right here. And your expiratory reserve volume is approximately 1,100 milliliters. So this is smaller than your inspiratory. So you can breathe in a lot extra than what you normally breathe in, but not quite as much when you breathe out. Okay. So then we have one last bit, see in this bottom part of our lung here, that is left over still. So that portion is called our residual volume. So on this graph, there's like nothing down here. It's just this empty. So just like our brain, our lungs don't use every bit of it to its best capacity. And so people that are athletes training for, different athletic events that are really going to push their body to its limits, they work to use more of their lung capacity. So this is about 1,200 milliliters that is left in this bottom portion. And that is called, like I said, the residual volume. And so that's what's left. We don't really use it. It's just there in the case that we could increase our lung capacity by doing different kinds of exercises and different kinds of things like that. And there's other types of values that scientists and doctors can look at with this. Another one that they can look at is something called the vital capacity down here. So this is the total volume of air that can be exhaled after maximum inhalation. So this is basically the tidal volume plus inspiratory reserve volume plus expiratory reserve volume. Okay. And then the last one that we have is the total lung capacity. So your total lung capacity is like everything. So it's the sum of vital capacity and residual volume. Okay. So your total lung capacity is this 5,800 right here. And that's always going to be about the same for every adult. It's an average. For males and females, there may be differences a little bit, but that's what your total lung capacity is. So your vital capacity is like what is usable air, whereas your total lung capacity is everything available within your lungs. Okay, so let's look at a different example of how this is shown. So this might help you as well to kind of categorize these in your head. So like we said, we have our tidal volume. You're breathing in and out. Okay, and this is the tidal volume over here as well. So they showed that here in pink as being between these two dotted lines. So when this spiral tab, you're actually going to be seeing something that looks like this, and you're going to have to be finding what the value of it is. And so you will have kind of a baseline that you're looking off of. And so then you'll be able to figure out what this value is. So always remember that, especially if this value right here was 0, that you would need to find the difference between these 2 points, which would be your delta Y. So that would be the change in the value of your lung capacity from this point here to this point here. And so you always want to use the absolute value of that, okay? And so then we have our inspiratory reserve volume. So when you're finding that value, when you're looking at the graph, you're going to go from the top of the tidal volume. So we're going to go from this point right here, and then we're going to go up to your highest peak, okay? And that's going to be your inspiratory reserve volume. Okay, so if mathematically you were trying to find that, you would need to find your delta Y of this point here to this point up here at the top of this graph here. So in Logger Pro, we're able to highlight regions, and it will tell you what that value is. But mathematically, if you ever had to do it, you would just need to find what the Y value for this point is, and then the Y value for this point up here, and then you would just subtract the two to find the difference. Okay. Then for the expiratory reserve volume, we have this one down here. Okay, so we have our expiratory reserve volume, and our expiratory reserve volume is obviously from the point in which we have our normal tidal breath, and we go down to where we have breathed out as much as we possibly can. So then you're going to find your delta Y of that. Okay, so you would find your change in Y from here to here, and that would be your value for expiratory reserve volume. Okay, so then finally for our vital capacity, if we're finding that, the vital capacity is from the difference between this very tip top point all the way down to your very bottom point here. So from your, inspiratory reserve volume peak to the bottom of your expiratory reserve volume peak. So something to keep in mind with this is that it's, the positive values going above this is for your inspiratory when you breathe in, and then this might be a negative value down here at the bottom when you breathe out. So you need to account for how much is above this line here, like how much is above this line and how much is below this line. So this is where you want to make sure you're thinking about it logically, that you would need to take like the absolute value of your expiratory reserve volume. So you'd want to take, for vital capacity, you would take the value of your inspiratory reserve volume plus the absolute value of your expiratory reserve volume. And then that would give your total, because you want this number, your expiratory reserve volume, to be positive. Okay. And then the final one is just your residual volume, which is whatever is left over here at the bottom. Okay. And usually I tell you that, like I don't make you figure that one out, okay? This is pretty standard for every person. I saw here on this first page is pretty standard of being about 1,200 milliliters, okay? So that is basically the basics of lung capacity. So go ahead and take pictures of your notes with following along with me, and then go ahead and put that in your OneNote journal. And I'm sorry I wasn't here today. And being able to do this like I wanted to. It's it's like one of those days where, when it rains, it pours, and we woke up to my kitchen ceiling being caved in because we had a pipe leaking. So my dad had to come up to help try to fix that while my husband is still at work. So thank you for following along, and I will see you guys on Monday, and we'll do this by Rama Tree Lab. So have a great weekend.